Hey everyone, welcome to another session of CeerazzleDazzlePhysics. In today's session, we're going to be talking about redshift. So what exactly is redshift? Well, it is the following. Okay, so before we get going, guys, you need to watch the Doppler effect video, which is on my channel. Watch that video before you do this lesson because you need to understand the Doppler effect before you understand redshift. So watch that video before starting this lesson. If you've watched it, we can make a start. Okay, so let's start off with the following scenario. Let's say you're on Earth and you look out into space and you can see a nearby galaxy. Okay, you can see a nearby galaxy. Right, that galaxy will be giving off light, and that light will be traveling towards you in the form of a wave. So the light coming out is traveling from the galaxy towards you. Right, but what would happen if the galaxy is moving away? What would happen to that wave? What would actually happen? Right, so right now we can see that the galaxy now is moving away. What's going to happen to that wave of light? Well, the same wave of light will come out, so have a look, but what do we notice? What do we notice about it now? Something has happened to the wavelength. So if you've forgotten what the wavelength is, the wavelength is this distance over here, peak to peak. This is the wavelength, symbol lambda. But now look, guys, if the object moves away, we know that the wavelength will increase. And this is due to the Doppler effect in that previous video. So we learnt about that last time, that if the object is moving away from us, the waves will increase in wavelength. Right, so we see an increase in wavelength. So if the galaxy is moving away from us, we see an increase in the wavelength. Okay, so what actually happens to the white light? Well, let's remind ourselves of the color spectrum. So we know that visible light is made up of red, orange, yellow, green, blue, indigo, and violet. Check out one of my previous videos if you've forgotten what that is. The wavelength of red light is the longest, so this one has the longest wavelength, and the violet side has the shortest wavelength. So red has the longest, the violet, or if you want to call it the blue side, has the shortest wavelength. So this is the longest wavelength, this is the shortest wavelength. Right, so on the red side is the longest wavelength, on the right side it is the shortest wavelength. Okay, so how is that going to be related to this thing over here? How is it going to relate to this thing over here? Right, you know that the light coming from the galaxy is going to be white. So what's coming out is white light. So white light is leaving that galaxy moving towards us. Yeah, all the way here. Right, so how would I get white light in the spectrum? So white light is right bang in the middle. So this line here, this is the white light. We know that white light, to get white light, it is right bang in the middle. So it's right bang in the middle because it has equal amounts of red and blue. So white light is this part of the spectrum. But you now know that if the galaxy is moving away from me, the wavelength of the white light will increase. So look again. If the wavelength increases, which side is it going to shift to? Think about it. If the wavelength increases, am I going to the left or to the right? Well, hopefully we can see that I'm going to be moving in this direction. Why? Because the wavelength is increasing. So I am shifting to the red end of the spectrum. Yeah, so the white light has shifted to the red end of the spectrum. Doing that again very slowly, it's kind of hard. So we said at the start we had a galaxy producing light. If the galaxy is moving away from us, the wavelength of the light will increase. If the wavelength of the light increases, for white light, which is bang in the middle, if the wavelength increases, I'm moving to the red end of the spectrum because look, we can see the wavelength is now longer. And therefore, this shift to the red end of the spectrum, this is what redshift actually is. So think about it. I shift to the red end of the spectrum, therefore it is called redshift. And that's what redshift is, guys. So this is exactly what redshift is. Redshift is simply when the wavelength of white light increases and it shifts it to the red end of the spectrum. This only happens when the object is moving away from us. So let's put that down then. So, alright, so summarizing, redshift, it's when the white light from distant galaxies, yes, white light from distant galaxies, increases in wavelength. So the white light from distant galaxies increases in wavelength, shifting it to the red end of the visible light spectrum. So when white light from distant galaxies increases in wavelength, shifting it to the red end of the spectrum. This is known as redshift. And this is observed for all the galaxies if you look at them from Earth. So what does that really mean to us? Okay, so let's look at this diagram to help us understand it. Let's say this is the Earth over here and all the galaxies around us, we look at them and all of the galaxies show redshift. Guys, they all show redshift. Yeah, so scientists found out that all of them show redshift. What does that mean? What does that tell you about all the galaxies? So if, let's say, for example, you looked at all the galaxies around you and you saw that all the white light had been redshifted for each and every one of them. What does that tell you about the galaxies themselves? Are they moving towards you or away? Well, we just learnt about this. Well, we said at the start that if the object is moving away from us, the wavelength increases. Therefore, we see the redshift. So therefore, if I know that all of them have redshift, therefore that means that all of them are moving away. There we go. They are all moving away. Right, so the reason why this is really important is because scientists found out that all the galaxies were demonstrating redshift. And if all of them are demonstrating redshift, it means they are all moving away. And therefore, if they're all moving away from each other, it means that the universe is expanding. So all the galaxies exhibit redshift, therefore they are all moving away. Therefore, the universe is expanding. So the universe itself is expanding. That is the key thing, guys, from this. So redshift actually contributes to evidence that the universe is expanding. Really, really important, guys. Right, so what kind of questions should you expect in an exam? It will be the following. So check this one out. So this is the type of question you'll get in the exam. So here we have, this is like a fingerprint of the sun. It's basically characteristics of the sun. This is an absorption spectrum. So this is an absorption spectrum. Absorption spectrum. Each of those black lines, these guys represent wavelengths of light absorbed. So these are wavelengths of light absorbed. So each of those black lines corresponds to a wavelength of light absorbed. Right, so the top one is for the sun. So the other one is going to be a distant galaxy. Right, the question is this then. Is the distant galaxy moving towards us or away? Alright, so to answer this question, we've got to look at the picture of the sun. We can see that all the lines from the sun, you can clearly see, they've all been shifted to the red end of the spectrum. So the distant galaxy has almost the same lines as the sun, but they've now been shifted to the red end of the spectrum. Right, so as the black lines have been shifted towards the red end of the spectrum, what does that mean? Moving towards us or moving away? Well, we know this. If it's shifted to the red end of the spectrum, it's going to be moving away. Right, so the reason why is because it'll be moving away from us because the absorption lines have shifted to the red end of the spectrum. And redshift means the galaxy is moving away. Okay, so that's the type of question you'll get. So make sure you can look at those little spectrums. Yeah, we can clearly see all those black lines have shifted to the red end of the spectrum. Therefore, redshift is observed. Redshift means the galaxy is moving away from you. And that's it. Right, let's have a quick recap from the top. Right from top, I'm not going to lie to you, it's a difficult concept to get your head around. So right at the start, we said that if we have a galaxy and it's moving away from us, the wavelength of the light increases. So what happens in the form of white light? Well, white light is right bang in the middle. The white light shifts to the longer wavelength. So the white light will shift to the longer wavelength over here, therefore moving it to the red end of the spectrum. Notice it's the red end of the spectrum here. This is the red end. We're moving towards this side here. So white light's in the middle, we move to the red end of the spectrum. And obviously, what does that mean? Redshift is when the white light from distant galaxies increases in wavelength, shifting it to the red end of the spectrum, the visible light spectrum, that is. How is that important to us? Well, if we look at all the light from distant galaxies, they all tell me about redshift. So what does that mean? It means that the universe is expanding. So that tells me that the universe is expanding because they've all got redshift now. And last of all, I did one example of what type of exam question. We've got the absorption spectrum from the sun and that of a distant galaxy. Well, we know that a distant galaxy, we can clearly see the lines have been shifted towards the red end of the spectrum. Therefore, it means that the galaxy is moving away from us. Difficult stuff, guys. I'm not going to lie. It's challenging. Get the wording right, guys, because they love to ask these type of questions in the exam. But I hope you enjoyed the session. Make sure you go over it, watch a couple of times to familiarize yourself with the concepts. But it's another session with me done. I shall see you next time. Make sure you like and subscribe to my videos. Keep the channel going, guys. Goodbye.